So the doctor has specified that there be a um, force of 50 newtons horizontally on this leg that's in traction of the pulley on the leg, 50 newtons this way, horizontally. And also that a 4.2 kilogram hanging mass should provide the tension in this string right here. And what we would like to do is we would like to figure out using a force analysis what the proper angle is, and that can be adjusted. So in order to do that, we'll assume a massless string approximation, and let's start with the leg itself. And what we're doing here is we're not taking any vertical forces into account on the leg. We're just taking horizontal forces. So there's a leftward force on the leg of the body pulling the leg to the left, and then there is a rightward force of the pulley on the leg. This is the one that's been specified to be 50 newtons. Moving over to the pulley, there's a reaction force to F of P on L, F of L on P, which acts to the left. And then there's these two tension forces. That would be one string angling up at theta and the other one angling down at theta, which are labeled tension P1 and tension P2. And then there is, because of the massless string approximation, a Newton number 3 pair between TP2 and TW. TW is the upward tension acting on the mass here. This is a free body diagram for the mass, and then a downward weight, the agent being the Earth, acting on this mass. So we can start with the pulley, and because this is a static situation, we can say that the sum of the forces in the x direction on the pulley are going to sum to 0, and that's going to be the x component of this first upward string plus the x component of this downward string, TP1 cosine theta plus TP2 cosine theta, minus F of L on P, which is acting to the left. Since these two tensions are the same, in fact, this tension is the same as this tension is the same as that tension, we can simplify this to 2t cosine theta minus F of L on P is equal to 0. And then solve this for cosine theta, and then take the inverse cosine of both sides to conclude that theta is equal to cos minus 1 F of L on P divided by 2t. So now if we move over to the hanging weight, it's also going to be acted on by the same tension that is in the other two strings. So that means that T has to be equal to the downward weight of this hanging weight, which is mw times g. mw being 4.2 kgs, that works itself out to be 41 newtons. So the tension in all three of these string segments are 41 newtons. And so we can go over now and put in the expression for theta, we can put the F of L on P, originally specified to be 50 newtons, and divided by 2 times T. Well, that's 2 times 41 newtons because of the mass of the hanging weight. And that turns out to be 52 degrees.